Hello, everybody. Welcome to the Neo4j online meetup. So we've got no Karine this week. She's out busy, so we just got me. If you've not met me, my name's Mark, and I work in the Neo4j developer relations team in London. Today we've got Stefan with us. I'm not going to attempt the surname, but Stefan wrote a blog post about using Neo4j for modeling and querying provenance data earlier this year, and we came across it and thought this would be a fun topic to have him share with you. So we're broadcasting this obviously live on Crowdcast. If you have any questions, ask those on the chat, and I will ask them of Stefan when there's a gap. If you're really skillful, you can figure out how to use the question functionality on Crowdcast, but if not, don't worry about it. And if you have any questions while you're watching this afterwards, have a look in the links on the YouTube description, and you can find the community site where you can ask any questions. So I guess maybe, Stefan, we can start off. Usually at the start of these presentations, we get people to quickly introduce themselves, maybe say what you do and how you first came across Neo4j, and I guess what was the first project you used it for?
Yeah, my name is Stefan. Hello, nice to present here today about provenance and storing into Neo4j. I worked with Neo4j, I think 2016 the first time, and actually the provenance storing project was my first project, and I came across Neo4j at the DLR, so the German Aerospace Center, and they work actually quite in bigger projects with Neo4j.
Cool. Okay, so maybe we can. So you've been doing it, I guess you've been using it for quite a while. So maybe I'll share the blog post that you wrote in case anyone wants to have a quick skim of that, and then maybe you can share your screen and we can get started.
Sure. So. So hopefully it's working. I can't see anything. Hopefully everybody else can see my screen. So yeah, welcome to our presentation about getting started with provenance and Neo4j. How to store provenance data in Neo4j. We learn a little bit about that. If there's any questions, I think Mark will just give me a hint and just to tell me the question, so to say. And yeah, let's start about that. First, I'll start with a little agenda. We introduced about provenance, the provenance itself, and after that we will talk about the PROV standard that I use to store it into Neo4j. Then a little bit about the transformation process, how we actually transform the model into a Neo4j graph. And then we see it in live action and some further development, what will be next and what could be next actually with these kind of technology. Yeah, let's start with introduction to provenance and see what we will get. The definition of provenance is basically based on the Oxford English Dictionary, the place known history of thing. That is one explanation what is kind of provenance. The historical definition of provenance is more like the ownership of an art or of an image, some of the art work, so to say. So if you want to buy an artwork, probably an expensive one, you should ask for the provenance of this artwork. If they can't provide it, it's probably like faulty or something that's not really clear with that work. In our modern world, actually, provenance is a wider term, so to say. It's more general use, and also to address problems with data, to address the provenance of data. And here we have the definition that the provenance of a piece of data is the process that lead to that piece of data. I will explain that a little bit later, but first let's just jump into a really, really simple example, what could be provenance data. And yeah, let's just assume we want to bake a cake, and the provenance information that is needed for these kind of activity is basically where are the ingredients from. So I need to know everything what we need for that final product, our cake, to be verified or to be stored in some kind of information. and also about the process of the cake preparation. So who was responsible for that, who done it, what kind of machine is used, for example. Also about the transportation, or the chain of producers and of agents, basically, that are used to handle the cake from the producer to the customer itself. It will be something like a distributor or retailer between them. And we want to keep track of that kind of chain. So that's actually quite a simple example, but even with this simple example, you see you need a lot of information to store this provenance information accurately. And you can really include there many details for this kind of simple example. If we move on, and in our modern world, actually, we are getting more and more data, and we always think about like fake news and other stuff where we need to trust these data. And that is where these sentences come into play. The provenance of a piece of data is the process that leads to that piece of data. And I will just give you an example where you probably will you will see that you use provenance on a daily basis, or at least on a weekly basis. So let's see this example here. We have our bank account, and we have quite a lot of money in that, and we see this bank balance here, 20,000 and a couple of euros. That's quite good for us. But one day later, we just look into that, and we see, okay, yeah, there is some money less. So we actually lose 200 euros. We can't actually say where we lost it, and we don't know it, and we can't actually trust that number because we can't see for what we spent that kind of amount. So basically, that's our piece of data in this area here. This 20,300, we can't really verify for what we paid these 200 euros. We need that kind of provenance data behind that. So I think everybody know what will came next. We have some kind of record for that, some kind of history system, in this case, some kind of transaction system that just display us what we need to know to make these calculations by ourselves, and to basically support our new account balance, and to give some evidence that this number is actually correct. So there we have our piece of data, and then we have basically our provenance data. So we see that provenance is not a new thing. So provenance is a thing of a daily basis and a daily life of many people. Another example would be like for software developers, typical example would be like version controlling system, Git, and so on. It's all about the provenance of a file, and we use that on a daily basis as a software developer. So let's just summarize why provenance actually matter. We have here two basically areas, so to say. First one is to improve quality, relevance, and trust. So we want to verify that our assumptions of some numbers, especially in calculations, are trustworthy. So if other numbers are trustworthy, our systems work correctly. And you can do that with provenance because you can actually verify it by your own eyes at least, or you can verify it by your own, by some systems to really see if it's working or if it's not working. The other one is in scientific way, we want to basically describe our experiment more accurately. So if you write a paper or if you create an experiment and you want to present that, you desire normally to describe that as accurately as you could, to provide some data for other researchers to reproduce your results, and also to create some evidence that your findings are real findings and then they are correct. Also for like fake news, and you want to say, okay, that's a fake news, you have to provide some evidence for that, and that's normally also done by some kind of provenance data. For other reasons, we can also have it like for debugging, improvement, and evolution. As a software developer, normally for debugging, you have some log entries, and you can use that as well. So, let's just start about that. So how we actually store these kind of provenance data. We saw there are bank transactions. You can actually see it as a table or just a simple relational data model. But there is, in this case, a more general solution for that. We have the VW3C PROV model. It's finalized since 2013, and it's a conduct of multiple standards, actually. So there are some serialization standards to save our data in XML, JSON, and a couple of more, and some other standard documents for creating the data model behind the constraints, so on. We wouldn't look today in each definition here. We just have a brief look into the PROV-N standard, because we use that to save actually the data, and the provenance model itself. If you're interested, the documents are all open. You can just look it up and see what's in there. So let's start with the provenance model. And the basic three concept of the PROV model is basically an entity, an activity, and an agent. And they are always related to each other at some predefined relations, but you can also in creating or extending for new relationships. There's just a fixed list of that. To get started is basically we have always an agent, or you should have always an agent that takes responsibility for some kind of activity. So if you have an activity, you want to probably know who is responsible for that activity, who performed that, and such information. The activity itself creates or uses existing or new entities. So basically, you can always create an entity by doing an activity which is done by some agent. And an entity could be basically everything, from our cake to a big car to a version of a file. So the entity is really wide concept, so to say, where you can have a version of your file, or a big car, or a home could be also an entity. Really depends on your case, what you need just for your special case. Let's start with our simple example, because we just saw our cake example would be a provenance model example. We can just transform our written example into these kind of concept. So if you can just see, we have here our basic concept, and we just transform that into our real world example. We have an agent that is Bob. Bob is responsible for the activity to bake a cake, and the cake was generated by basically the activity to bake. We have a start and an end time, so we can actually put there more properties and more information on each node, and also on each relationship. And I extended that here a little bit with some kind of ingredient and another activity to buy the ingredient we need to do something. Of course, that's just a simple example. We could also extend the buy activity, and the ingredient should also be separated to have several ones, and so on. And probably would also to know who bought it, because I don't know, you forgot something or something like that. So that's our simple example for our cake here, and we transformed that from a real world example that is written into our concept view. And then we will transfer that just into a PROV-N standard. I would just like to show you how it looks like. It's a human readable form of saving provenance documents. And it is basically, as you can see, on the right side, the diagram written down in a textual format, which is machine readable. It's just used for representation for human readable transfer of data. Okay, now we come to the interesting part. Actually, we try to transform this one into a graph, and there's where Neo4j come in place. And what we actually done by the project that I started in 2016 is that we used these provenance graphs and saw that they are so similar to normal graph that you can actually represent that directly as a Neo4j graph without the need of creating big database concepts for relational tables or something like that. So as you can on the left is most likely the structure on the right without any need to modify that, which contains all the information that you need to also query that. So that is basically our transformation that we took. So we basically say we have our three concepts, agents, entities, and activities, and put that just into Neo4j as node labels. Yeah, and we actually added some also meta information for each node because it's necessary because of the format and of the format and specification itself. But in general, we just save what we see into Neo4j. From the code perspective, it looks just like this here. We actually created a library that is used for storing provenance data into Neo4j. It's written in Python, using the official Neo4j adapter, and the library for serialization and deserialization of provenance documents. So we just see here to create a new instance of our API with the simple authentication information and creating a new document where we see Bob and Alice and some association between them, and save that document and get it back from Neo4j and print it out as a PROV-N document. So basically we save it once, get it back, and see the results. Good. So just have a little conclusion about that part, what we learned right now. We just learned about the VW3 PROV standard, how to store their data, using the PROV-N representation to import this into Neo4j, creating a graph structure based on that information. And now we can actually use nice Cypher queries to query our data and to get information out of that. And yeah, I think let's just do that and create some really nice graphs. Oh. So I just want to show you before I can. So here we see actually the simple example that I showed before was Bob and Alice as code example, just in an example file to execute that and to import that into Neo4j. Right now, we just clear the database. Oh. That's better. So we just clear our database. We don't have any relations. We have an empty database. Let's just import that one into Neo4j and see how it looks like. Today I have a typo. So actually right now we have an agent and activity and some kind of association between them. And we actually can see that just worked as we expected, just like at the normal, as our document we see here, we have our graph representation of the document. So if we would like to extend that, for example, if we want to just have a new entity, which is performed by an activity, prov document activity, and we have a new association between them. and we have a generation. So was generated by a specific activity. We can just import that again. And if you can see, our graph should now be extended and just represent our new state. Really, our entity here was generated by some activity which was associated with a specific agent, which is also associated with another activity that is called Alice. I don't know why this example showed like that, but that is right now our data case. If we look into the properties and relationships itself, we can see we have here some information behind that. Most likely ID information, but also like some other namespace information that is just necessary for the representation of the format itself, because we don't want to store any kind of external data, just want to store everything here to perform a transformation from Neo4j also to PROV-N. So that is the reason why we have these namespace information. Okay, that actually looks quite simple. So you probably wonder why you need actually this kind of provenance information. But if you're looking into that kind of example, which is a little bit bigger, you probably will see that here you can't actually say what is connected to what, and you have a big of a graph of a mess. If you can't query that, that's actually quite of a hard task. This actually example is I don't know if it's a real world example, but I found it at a public data set. It's called Horsemeat example, and it could be at least a real world example where somebody produces meat, somebody orders meat, and somebody actually delivers meat to the customer. And with this example, you can actually answer some nice questions. So let's just start with try to get to know which agents are involved in the process of producing my order. And if I just pick my order, I think I have it here, yeah. Oh, sorry, I just need to import that first. So let's just import that Horsemeat example. We have it here. It's also
so with the Horsemeat one, will you load it from the file directly?
Actually you can load it directly from the file. We have it. I included that into the library as some examples. So we have here the Horsemeat example, which is represented in a JSON format, and that is actually the whole graph that you need to import.
I think it's a little bit. Only the JSON only just came up now. Maybe you can just. I think it's a little bit delayed from when you said it. Maybe you can just quickly put it back on the screen again. So maybe just explain one of the sections.
Yeah, sure.
Yeah, thanks.
Sure. So basically, we have here the representation of this Horsemeat example as a JSON in a JSON format, and here we have for example, all the entities or most of the entities with always like a namespace before that, and yeah, let's just look it up.
And so do those items under the entity key, do they become nodes when you import it?
Right.
Okay.
Yeah, right. So basically, this will here transformed into a provenance document instance, and then they will transfer it actually to nodes and edges. So all the agents and activities and entities will transform into nodes, and the relations between them into edges, basically. Okay. I actually didn't look up into that format because it's like provided by the library, but they will transform it as well into like a more readable, more processable class instance, so to say. But we can just look it up. I will just import that and then just show the DB schema, and you will see that that it is actually quite simple.
Cool. I'm gonna share the link for the library on the chat in case anybody wants to.
Yeah, sure.
I think the from your blog post, I don't know whether it was the case when you wrote it, but the store of all the provenance documents, at the top it has a big warning saying this is going to be removed soon, and it points to open provenance.
I saw that a week ago as well, and I will modify the blog post, I think tomorrow, something like that, to the new provenance store. They actually just moved around. They changed actually just the hoster, or they changed actually the university, and they wasn't permitted to transfer the data. So they set it up new.
Okay. And so the idea with that open provenance is that people would all share, like, are they like canonical examples of generic provenance data, or are they very specific for one problem?
It's really depends on. There are really generic provenance data, like sample example data provided by the standard as well. But there's also like really specific ones. So for example, there is a tool out there that transform Git repositories into these kind of provenance representation. And you will find there some Git repositories basically stored as provenance at the PROV store. That's really big documents.
Oh, cool.
You will see that it will take a long time to produce some graphs and stuff like that. But you can basically just scrape the Neo4j repository into a provenance store.
So what it would be like tracking the provenance of like a file, like the way it evolved or something like that, or what would it?
Right. They basically transform all the information that is in Git present. So when it was modified, which line was modified, which file, who was it, and so on, into these kind of graph structure. So basically, you can save your Git repository into Neo4j.
It sounds like a fun project.
Yeah, I didn't have the time. Otherwise, I would try that, but I didn't have the time today to just test that out.
Yeah, we had a previous meetup where, or at least maybe not a meetup, but it's certainly a presentation by Christoph Willemsen, where he was showing how to load data from the GitHub Events API into Neo4j, which I guess is slightly different data, but maybe there's some overlap in what you see in the provenance one.
Yep.
So.
Yeah, for the provenance data is actually the idea to build a more general model instead of just for files like Git. Git is just for files, but for the software development process, for example, I would just come in my mind that it's also like interesting to know, does the CI run through that, or does the CI pass and stuff like that. And this provenance model is basically to store these kind of more general data in a certain way and in a certain format to query it actually. It shouldn't be depending on the provider, for example. If you use GitHub, GitLab, or something else, the format should be always the same, and you can build some cool product that summarize that.
We've got a question for you from Marcio Sugar. It says, are there any examples relating databases, tables, fields, and processes that change or transform or update data? So I guess this is a question of, can you get provenance on the evolution of a relational database changing?
Yep. Really good question. We had actually also the idea to store these kind of data. I'm actually thinking about to implement that in my current company because it's necessary. But right now I didn't know about that. But I'm pretty sure that you can do something. For example, if you're building some kind of history data system, so to say, if you want to track the history of database changes of a certain entity or something like that, it's just the format that is changed, basically. So you can just choose if you try to save that in a provenance model, or if you want to just save it in a MongoDB or something else, or directly into Neo4j to store these kind of information. But I'm not aware that there's a product out there.
Cool. Yeah, I guess the most meta thing you could do would be to build a provenance graph of the changes of a graph of data changing in a graph.
Yeah, that is also nice project, I think.
I've got a follow-up question. How would you, if you had that provenance graph to start with, how would you then add other concepts? So I guess this is almost like an ontology. So how would you add like business terms for a glossary or organization or system?
Yeah. So you basically label that as an agent. An organization is also an agent, and you can have like different. For example, you can have different properties on that. There is, for example, this kind of prof type where you can just say, okay, yeah, that is a schema organization or something like that. So you basically have you have to think about your business requirements and what you need actually to store or to query that in your way that you intend to. There are some best practices out there also described in this standard, but in general, it's totally modified. So you can basically add just the property, it's an organization or it's related to something, and then you can just query that.
Okay, cool. I guess we can go back to the Horsemeat.
Yeah, sure. I just want to, probably just show you the example and how to import that. And yeah, so we just imported our Horsemeat example, and if we just return our graph right now, it's a little bit messy. We see some different activities, entities, and some agents here, but we can't actually see anything that makes sense. We can make out something like mixed as an entity because we saw that there is a big bundle of mixed and we see some associations. If we call db, I really don't know how it looks like because I didn't test that, but actually it doesn't look so bad. Just to show you the actual model that is behind that, you can see that it is quite simple. And if I just change it in the right way, I'm pretty sure that you will see that this model here is not so far away from our model that we saw in our presentation. And this presentation model was not from Neo4j or something like that, but it was just from the VW3C standard. So we actually saved it exactly like it should be saved, or like we actually got it, and represent as nodes all activities, agents, and entities, and everything else as a relation.
This the yellow node is a bit hard to see it. Maybe you click on, maybe you can make a different color, maybe easier to see.
Yeah, maybe that is good.
Oh yeah, that's a bit better. Thanks.
Yeah, it's fine. Okay, so that's actually our model. Quite simple, not so many labels, few relationships, and that is actually what we get if we import these big, or not really big, but our graph model right now. So if we would like to, for example, find out what kind of agent is involved in my product or producing my product, we will just find that out if we create a nice cipher that is based on my starting point with some kind of identifier. So that's actually how you model your data. That could be also like your order number or something like that. And then we find all agents that are related to that. That is actually one thing that you should know, that these graphs don't have any cycles. So they are only directed graphs. They can't actually have loops, or they shouldn't have loops actually. So if you go that way into this direction and find any agent, you should find any agent. There aren't any agent in the other way around. So let's just find our agent. We see we have here three agents. Just label them at some point. So we have here three agents that are basically involved in the process of producing or transporting or getting the product to me for my order meat here. If you want to just print out the location, for example, we have these kind of prof at location, and that is actually not a standard. I'm pretty sure that that is not a standard standard property. So you can actually modify that as you please to, and add just the location and just use it as you need it. And we just found out that somewhere in Luxembourg, France, and United Kingdom, my order was processed at some point somehow. Yeah, that's actually one probably usage for doing this. You can also imagine that you don't have just a simple product where you just have a few hops, but if you, for example, try to produce a car with several thousand parts, the parts are consisting of other parts, or an airplane or something like that, and then you would like to query who was responsible for that or who is in this chain of producers, then it's getting a harder task to do by manual finding out by, I don't know, reading some files, and it's better to have it in some kind of database. Yeah, the other way that I also showed in the blog post about this one here, I want to just find out from a certain point in my graph where's my slaughter, who slaughtered actually my meat here in this case. And I just formulated this graph, and the use case could be something like, okay, I found there some kind of a mistake, or there was an error, or the quality was not good. I want to just find out who was responsible for that, and I just get it back. And maybe to be noticed is that provenance data could be also stored around 10 or 20 years. And during that 10 or 20 years, probably the chain will somehow the chain will change. So I change my manufacturer, I change my process behind that because I want to involve my business. But these graph data doesn't have to change, and also my query doesn't have to change because I don't know about the steps between them. I just know, okay, I want to have the person who is responsible for that activity, and I get it. No, never mind, or nevertheless, that the process between them could be evolving over time. So yeah, I just get it back here. Just got my simple thing back, and somebody asked about the organization, or how would I just mark that, and here we have it. Actually, that is an organization. We have an agent with an prof type. This is EMA organization. So that is one possibility to store that actually. Okay, the other one is the last one actually. I want to just starting with my order and find all activities that are basically in the shortest path around that. I just created that today, so I didn't analyze it totally deeply, but you can see actually that we have here find out the nice chain of activities that is used to get or to generate actually my entity here. So we have here actually place an order, we have here place product 2, and we have here place product 1. I really don't know right now why we don't have anything like, I don't know, growing the meat here. So probably the model is not complete, or there's some kind of data flaw in that, or I modified my query not really well. But yeah, after some investigation, I would definitely find out the reason for that. Even here, you don't have to change around the query. If your process changed, you don't have to take care about that, or most likely not to take care about that. Yeah. Okay. That was a simple, or a more complex example than our baking a cake example. To just summarize that here, we have here a bigger process with a few nodes, a few activities, and a few orders in that case, a few entities. We queried that a little bit and saw that we can get out some information based on our data. And what I would recommend at that point is, if you have these data and you want to store them for a long time, and you expect that something is changing in between. So for example, you change your manufacturer, something like that. Especially if you model your provenance data, try to stick to the specification and don't create so really complicated models, because then it will get harder to query them like in a general way. And then the queries are more relied on the structure behind that, and that could be a problem if you have an involving progress. Okay, so let's jump back to our presentation.
Nicholas points out that this use case is very similar to doing like food traceability.
Yeah.
Trace1 was our company that used Neo4j to do that. I think they may well have presented on that before. Have you ever done any stuff with food tracing?
I'm actually no. I didn't track any food tracing. That is just a document from this public PROV store that they provided that actually, or somebody loaded up, and I found it was a good example. Maybe I can just I should start with that. The reason why the DLR is investigating this kind of technology, so the provenance technology, at least one idea behind that is that they're creating right now a debris system. So I would like to predict some debris in the space. And for these kind of predictions, it's really important to have the provenance data, because you just get a coordinate basically and some kind of direction. And if you can't trust these numbers and you can't actually debug that, then it's getting really, really hard to improve that system. And that is actually the reason why this kind of provenance technology is involving at that point. Also because it's interesting. Okay. So I just jump into my few last pictures to summarize that. That's also the Horsemeat example. Okay. A little bit about the further development. What I know, I didn't work there anymore, but what I know is that right now they are using this kind of library to store actually provenance for machine learning. A very similar problem. You have basically, if you have a regression problem where you have just percentage probability of your machine learning algorithm as an output, you want probably to know why did the algorithm decide that this is 90% a cat, but it isn't a cat. So this kind of information could be also stored into Neo4j, or as provenance information at least. Then you have basically big field of building visualizations based on that provenance. So for example, I picked out here some kind of a comic visualization. These are not drawn. These comics are basically based on the provenance data that we just saw. So agent activities and so on, and they just will be replaced by some images and filled with some meta information. And the third one is definitely to improve the performance of this library, because right now it can get really, really slow if you import big chunks of data. That is actually so to say, an engineering problem. Okay, that was it. Have you any questions, or I would like to answer them?
Cool. Yeah, we'll give people a few seconds to come up with some questions for you. I think one which I missed before, which was a kind of continuing from another question, was asking, how do properties from the provenance model translate to properties in the Neo4j model? Do they map just one-to-one, or do you create nodes from some of the properties, or how does that translation process work?
They actually translate one-to-one, basically. Okay. I will just prefix them with prof something. I will just create a prefix to ensure that this is a property that came from the original input, And we have some meta information like these namespaces and some type information that is needed to be stored at each node. But
cool.
actually, the labels and properties are stored one-to-one.
And Nicholas asks, have you looked at using provenance in deep learning as well in order to prove there's no bias within an algorithm? I guess that's extending on the machine learning that you pointed out.
Yeah. I didn't know about that, but that's actually a good point. That you could prove that there is no bias in there. At least you can prove why that decided at this direction or something like that. So you can find out the reason and prove that it's not the reason that you probably think from the first picture, so to say. But that's a good point, actually. At least I didn't thought about that. I have to ask the next colleague if they thought about that. I just know that they will research about that.
Cool. All right. Well, I guess if nobody else has any questions,
that's fair.
Then I guess thanks for coming and presenting to us. And I guess if people want to learn more, they can always read your blog post, and I shared the library as well. And we look forward to seeing if somebody takes up the challenge of making a GitHub graph of Neo4j showing the provenance of the development of Neo4j in Neo4j.
We will see about that.
Awesome. So thanks, Stefan, and thanks everybody for coming to watch as well.
Yeah, thank you for
watching.
watching.
See you next time. Bye-bye.
Yeah, bye.